All right, chemistry students, this is the last notes for Unit 4, all about moles, and we're going to talk about how to convert from grams to moles and moles to grams, so back and forth between those. So let's hop right in to this. All right, so let's talk about how to convert between different units, because that's going to really help us out here. I'm going to teach you a method. It's called the skeleton method, and I think you'll see why in just a moment, but here we go. All right, so I've written up a question right here. So how many centimeters is 8.3 inches? So if you wanted to convert these units, that's really all we're doing here is converting units. You need to know the conversion factor. I also refer to this as an equality. So this right here, okay, that is our equality or conversion factor. I like to call it an equality because it has two things that are equal to each other. I think that makes a lot of sense personally. We'll see if you do as well. Otherwise, a conversion factor also works because it's the numbers that you use to convert between two different things. So I'm just adjusting the overhead. All right, that's fine. That'll work. Okay, so how many centimeters is in 8.3 inches? Well, we're going to have to do some sort of math here. It's probably going to be, usually when you're converting things, it's pretty obvious you're going to need to do some sort of calculation, and it usually involves multiplication or division. And the hard thing to figure out is which one. So this is why I like to use this skeleton or unit canceling or dimensional analysis method. It's pretty foolproof. It works all the time, and you let the units guide you. So the first thing you have to do is take this equality. So we know that 1 inch is equal, sorry, to 2.54 centimeters. So the way I like to think about this is it's kind of like if you said like 1 is equal to 1. These things are the same as each other. Or x is equal to x. Okay, those are the same things. Now, because these two things are equal to each other, we can rewrite these in a different format. We can write them as a fraction. So if 1 is equal to 1, if we write it over like this, 1 over 1, that still equals 1. Everything works. So same thing, if x is equal to x, you can write this as x over x. If x is equal to 2, you can write this as x over 2, or even 2 over x. And all of these things, these numbers are basically equal to each other. The principle now is that if these are all essentially equal to 1, right, then you can multiply any number you want by 1, and it doesn't actually change the value of the number. It's still 1. So that is the basic principle behind a conversion factor, is that you're taking an original number and multiplying it by 1. So let's do that. Let's give it a try. If you take 1 inch and 2.54 centimeters, let's switch it into this equality format or kind of a fraction format. So we could write this two different ways. We could write it like this or like this. Okay, so I'll make these little ones so you can tell that they're not lin, whatever lin is. I don't think that's a math thing. Okay, so 2.54 centimeters over 1 inch or 1 inch over 2.54 centimeters. Both of these, if you divide those two numbers, will equal 1 because they are the same thing. If you grab a ruler, you can totally confirm this very simply. Okay, so the idea behind this is if we're looking back at our problem, let's try to solve this. So how many centimeters is in 8.35 or 8.3 inches? So whenever I'm solving a word problem like this, the first thing I do is I try to figure out what I'm solving for. In this case, I'm solving for centimeters. And I usually put a box around it so that way I remember this is what I'm going for. I also like to keep track of my units. And my units are going to be cm, that's for centimeters. So my final answer had better be in centimeters, otherwise I've done something wrong. Okay. I also underline any important information that I'm going to need to use. So 8.3 inches is where is the information that I am starting with. And that's what I need to convert. So the way that I like to think of this is I always start with the number that I've been given in the problem. So we have 8.3 centimeters and I need to convert, or 8.3 inches, and I need to convert from into centimeters. So I'm going from inches to centimeters. I'm going to start with the information I've been given, 8.3 inches. And I need to multiply this by whichever version of my equality is going to cancel out the unit I don't want and give me the unit I do want. So what I mean by that is, if you think of this also like a fraction, right? And we're going to multiply, it's like multiplying fractions. If units are just like numbers, you can cancel them out and multiply them and divide them just like any other units. You actually know that already, right? Because if you have to do, for example, real quick, just off to the side, if you have a square that's 1 centimeter by 1 centimeter, and you're saying, hey, what's the volume of the square? You're going to take 1 centimeter, multiply it by 1 centimeter, and your answer is going to be 1 centimeter squared. So that unit is multiplying the 2 centimeters together. So that should be kind of familiar to you, the idea of multiplying units. That's not completely foreign. Okay, so we're going to take one of these two fractions and put them right here. That's the line that represents the fraction. So I need inches to be on the bottom so it cancels out, and I need centimeters to be on the top because that's the unit I need. So I'm going to choose this one. Okay, so all I'm going to do is take this equality that I got because I know what 1 inch is. I know 1 inch is 2.54 centimeters. I turned it into a fraction. So just took that information, wrote it in a slightly different form. And now I'm going to put it into my equality. So I'm just going to like pick this up and drop it right here. So 2.54 centimeters over 1 inch. Okay, how's that look so far? Well, you can't answer because you're not here. All right. So once again, these inches, because there's an inch on top and on bottom, you know from basic math, when that's true about fractions, you can cancel. So those cancel. And now all we have to do is multiply across. And obviously, if it's on the bottom, we would divide. Dividing a bottom, multiplying across. So in this particular case, it's going to be 8.3 times 2.54. So let's just do the math. Okay, 21.08. Oh, by the way, I say for rounding, just go to the hundredths place. So 2 places past the decimal. And that's always uniformly. Just do that and you'll be fine. So that is 21.08. And the units are centimeters. Don't ever forget your units. That's super important. Okay, and that's our answer. If we go back and look at the question, 8.3 inches is 21.08 centimeters. Our answer is written in centimeters. We've canceled out inches. An inch is more than a centimeter. So an inch is almost 3 times as much as a centimeter. So it makes sense that our answer would be bigger. We would expect there to be more centimeters than inches. So it's also a really good idea to double check your answers to see if they just make sense. Like, is that logical? Would you expect that? You don't have to know the exact number, but being able to kind of predict it, say like, oh, this answer should be, the centimeter should be almost 3 times as much, somewhere between 2 and 3 times as much. Well, 2 times 8 is like 16, 3 times 8 is like 24. This is somewhere between 16 and 24. So that seems pretty reasonable. Okay, so this is a really, really helpful method that you can use all the time. I've had students who take like standardized tests like the AIMS and even the PSATs or SATs that will ask you to do unit conversions. And this method, I have very often had students tell me how useful it is. So let's talk about skeletons. Skeletons are this exact same method, just drawn a little bit differently. Instead of doing 2 fractions with a multiplication in between them, I like to make these little grids. The grid is the exact same thing. Actually, I'll switch colors just so you can kind of see a little bit of a difference. There we go. Okay, so this grid is the exact same thing as two fractions being multiplied. The rule here is if the two numbers are across from each other, it's multiplication, even down here. And if they're on bottom, top and bottom, it's division. So you're going to take all of your numbers. You always start with the information from the problem. So once again, in this case, it's 8.3 inches. You always include the units because otherwise you can't cancel out units. You got to include units all the time. Okay. By the way, I take off points if there's no units. So get used to doing units. Otherwise, you're just going to get points taken off. And there's very easy points. So if you're going to miss points, it shouldn't be on units because they're very simple to include. All right. The next thing is this spot. We usually leave this spot blank just because it's not an equality. It's just a number. It's the number we start with. So that's typically blank. And then again, you're just going to drop in equalities into these spots. What's really great about this method is it's really easy to keep organized. It's a little bit simpler, I think. I mean, if you prefer this method, that's fine. If you prefer this one as opposed to this, it's the exact same thing, but you can choose either you like. We're going to, again, drop the equality into the spot. This box here is where you put in equalities. Okay, so that's the entire purpose of that, is just a place to put an equality, and you can flip whichever orientation you need it to be in. If you need to switch which one's on top and which one's on bottom, no problem. But in this case, 2.54 centimeters per 1 inch. It's exactly the same as up here. The inches, one is on top, one's on bottom. And once again, you just multiply. And you're going to get the exact same answer, 21.08 centimeters, right? So this method is really helpful because you don't have to ask yourself, do I take 8.3 and do I multiply it by 2.54, or do I divide it by 2.54, or do I take 2.54 and divide it by 8.3? I mean, these are all things students try to do all the time and get very confused on. So this is extremely normal if that's confusing to you. If you learn this method, it's a little weird at first, but once you get it, if you learn this method and you use it correctly, the method does the work for you. You don't have to figure out whether to divide or multiply. You just do whatever the skeleton tells you to do. So once again, you just divide. There's not really anything in the bottom. There's just a 1, so we can ignore that. Anything on the top, it's just like fractions. You multiply, and that's it. Okay, so that's my little introduction to unit conversion, dimensional analysis, whatever you want to call it, and skeletons. Oh yeah, by the way, why do I call it skeleton? Well, this is a one-step skeleton. It has a spot here, but you can make them bigger if you want. We're going to end up doing skeletons that are at one point 3 steps like this. There's a spot for 3 different equalities. Equality 1, equality 2, and equality 3. Okay, we'll get there eventually. We'll build our way up to that. But anyways, if you look at this, it kind of looks like a rib cage, on its side, like there's the spine and the ribs. They're also known as train tracks, again, because they kind of look like train tracks. So it's just an organizational tool. That's pretty much it. I will tell you this. When I was in college physics, I was really, really struggling with it. It sucked. It was really hard for me. And the only way I survived was with this method. I didn't always understand what I was doing. But if I could cancel out all the units in a way that sort of made sense and get to the end where the unit that I think the answer was asking for, I did okay. I didn't always get the right answer, but at least I got close and got some partial credit for like reasonable logical thinking. And the same is true for you. So if you're ever struggling and you're not 100% sure what to do, try canceling out units. The only hard part is figuring out what the equalities are and which ones to use. In this particular case, we knew which equality to use because we were going from inches to centimeters. So all you had to do was find an equality that has inches and centimeters in it, which we had right here, or we could look up. A lot of times it's not given to you in the problem. You have to find it yourself. Hint, molar mass. Okay. So speaking of, let's go into molar mass a little bit. So if you want to grab, if this is confusing for you, there's another video I'm going to post that might help you. And we're going to work on this in class a lot. But if this is the part that confuses you, specifically ask me for help with this. So I get really, really annoyed when students just ask me, like, I need help. I don't understand. I'm like, great. What does that mean? But if you can tell me, I'm confused about equalities, or if you can be even more specific, like, I'm confused about how to fill out a skeleton. That will help me, give me a place to start, and then we can figure out what's going on. Okay, so that's the basics of equalities and the skeleton method. Let's go into the notes. The notes, you're going to take some notes right here, and you're also going to fill out the second half of notes. You already have taken the first half here. So this spot, we're going to do one problem here, and one problem here. So try to leave yourself some space. You should have like a line here. Next time I'll fill these in for what you should have had. But that's okay. Go back in notes if you don't have, if this is all blank for you. Yeah, you should have this. Should have some stuff in it, and there should be some stuff here. These are the two sections we're going to fill out right now. So let's do that. Okay, so let's try this with molar mass. Okay, so converting between moles and mass using skeletons, that is the goal for today. So here's an example. All right, so what is the mass of 0.65 moles of zinc? So when you are trying to solve this problem, you got to think about what are we starting with and what are we and should we be ending up with? Well, in this case, we're talking about zinc, and we want to convert from moles to mass. So you got to think for a second, what are the units for mass? Well, the units for mass are in the SI system, in the metric system, are always grams. So we're going to go from moles to grams. So now we need to think of what is an equality or a conversion factor that will get us from moles to grams. Well, if you look just a little higher up in your notes, you're going to find that molar mass is going to fit the bill. It has both units in it. It always has to have both so that you can cancel out one of the units you're starting with and end up with the units that you want. So just looking right up in your sheet, I think you have the molar mass. Otherwise, it's on your periodic table for zinc, which is 65.39 grams per mole. And you already have it written in equality format. So let's set up our skeleton. It's this little, for this one, it's just going to be one step. So we've got a place to put our first number and a place to put our equality. So the first thing we're going to do is put 0.65 moles. You always need to include units. That's really important. Now, instead of moles, you could put MOL. That's the abbreviation for mole. I don't know why, we just cut out the E. It's not that abbreviated, but there you go. All right, next thing we're going to do is we need to put in the equality right here. So we need to put in the equality. There's two options, and you have to figure out which one it is. And you're just going to kind of drop it in place. So wherever that line is from the decimal or from the fraction line, it's this line is the same as this line right here. So we need one where we want grams. So whatever unit you want has to be on top, and we need to cancel out moles. So moles need to be on bottom. So we're going to use this one. So it's 65.39 grams per 1 mole. Okay. So again, if you noticed in your equalities from before, it's one of those and just kind of dragged and dropped into this spot. If you sort of covered up the 0.65 part, you would see that it's just a fraction. The dividing line here just means we're multiplying or dividing. So if we go through and do this, this is telling us that we need to multiply those two numbers on top and divide by whatever's on bottom. So that's going to be 0.65 times 65.39 divided by 1. So we can ignore the 1. We don't have to worry about that. And these moles cancel out. So units can cancel just like numbers can. And we're left with grams, which is exactly what we were trying to solve for. And so now we can get our answer. If you plug this into your calculator, you will also get 42.50 grams of zinc. Okay. So that's kind of how we solve these. Now, just to let you know, a problem like this is usually worth like 5 points, or it can be, depending. If it's worth 5 points, like they are in a quiz, you get a point for units. So if you don't have grams here, or you have the wrong unit, that's automatically 1 point off. You get a usually 3 points for the work, and then 1 point for the correct answer. So if you show work, you can still get a lot of points. You won't probably get the full 3 points if it's not the correct work, but if you make a mistake along the way, for example, if you use the wrong molar mass, I'll probably just take off 1 point, maybe 2, 1 for the wrong answer, 1 for the wrong molar mass. But yeah, as long as you show some work, you're gonna get at least 1 point. If you don't show any work, but you give me the correct answer, you only get 2 points out of 5. So you have to show work. How that's gonna work online, I don't know yet, but I'm gonna figure it out. So we'll get there. Okay, let's do another example. All right, how many moles is in 1,652 grams of plutonium? So let's take a look at this one. Well, this time we're starting with grams and we're going to moles. So if we set up our skeleton, we've got that there. We're always going to start with whatever number we've given in the problem and put it in this first spot. We don't really ever put something in the bottom. I mean, you can, but you usually don't. The next thing is we're going to need to put some sort of equality here that is going to get rid of grams. So grams has to be on the bottom. And we want moles, so moles needs to be on top. In this case, we have molar mass. That's easy to convert. We just have to orient it correctly. So grams per mole. Once again, we got that from the periodic table. Now, a quick reminder, the numbers on the periodic table are always the grams, and it's always per 1 mole. So you're never going to have a different number there. So all the numbers in the periodic table are automatically the number that goes with grams divided by the number for moles. In this last example, we had grams over moles. In this example, we have moles over grams. They're both fine. It just depends on what the problem requires. Every time it's a little bit different. This is, again, the part where you're going to let the units guide you. Okay, so now let's do the math. So the math is saying that anything on top we multiply and anything on bottom we divide. So in this case, it's going to be 1,652 times 1. So that's nothing. That's the 1,652. And we're going to divide that by 244. So in this case, the grams will cancel out. We'll be left with moles. And you end up with, if you do the math there, it's 6.77 moles of plutonium. Okay. So again, hopefully by looking at these two examples, you can see that sometimes you have to multiply by molar mass and sometimes you have to divide. And it just depends on what you're starting with. If you ask me if should I multiply or divide, I'm going to say, I don't know, figure it out. Use the units, let the units be your guide. That's how you figure it out. I don't memorize this. Technically, there's probably a formula I could use or something, but I don't want to memorize anything. And this method means I never have to memorize anything. I just set things up and let the units cancel themselves out, and it works out very nicely. It's a little tricky right now, maybe, might seem a little strange, but in the long run, trust me, this method is going to be very, very, very important. So please learn it now. We'll work on it more together if you need it. Okay, so that was the examples that went in this spot right here. Let's do this last one. Okay, so this was using molar mass for elements. You can still do this. One second. For compounds as well. It works just the same. So if you remember, oh dear, what's happening here? I'm going to stop just in case I can't 100% tell what's going on here. One moment. Okay, here we go. This is definitely working. So in the last video, we talked about finding the molar mass of potassium phosphate. So I'm going to run through that with you. Let's read the problem first. So how many moles are in 12.3 grams of potassium phosphate? So to solve this problem, we know we're starting with grams, and we know that we're going to go to moles. So if you want to go from grams to moles or moles to grams, if you want to convert between those, you're going to need the molar mass. So we need the molar mass of potassium phosphate. So the molar mass is not given to you, except it's on your periodic table. So first step is you need to figure out the formula for potassium phosphate. If you don't have the formula correct, you're going to end up with the incorrect molar mass. So this is where writing formulas is super, super important from Unit 3. So potassium phosphate, if you figure it out, it's potassium is a K plus 1. Phosphate is PO4 minus 3. So the formula is going to be, excuse me, K3PO4. So again, if you end up getting this wrong, your molar mass is going to be wrong. and then your final answer will also be wrong. You can still get partial points, but it's really good if you can write the formulas correctly. It's important. Okay, so now we need to figure out the molar mass. Just like I said last time, it's going to be the molar mass of 3 potassiums plus the molar mass of phosphorus plus the molar mass of 4 oxygens. Again, because that's what it says right here to do. So we'll add up all the molar masses and we get our molar mass of the compound, pardon me. So this is grams per mole. Now the next step is to solve using the molar masses inequality. So we can set up our skeleton. We're going to take the number from the problem. So that's the 12.3 grams of potassium phosphate. And we need to put this equality into this section. So we're going to take this number here with the grams per mole and put it into the equality. So in this case, we want moles on top and grams on bottom. The number always goes with the grams and it's always per 1 mole. So we should have 1 mole on top and 212.27 grams on the bottom. So again, you can see, because I did this in purple to help you see, this number and configuration comes directly from here. So this equality just gets smooshed in like that. This bottom box doesn't really have anything. We just use this as an organizational tool. Once again, we can decide if we're going to multiply or divide. In this case, it looks like we're going to multiply by 1 and divide by 212.27. So it's pretty much division. And here's the other thing. Sorry to get sidetracked. A lot of times when you're doing these numbers, it's really easy to forget which order they go in. For multiplication, it doesn't matter. But if you do 212 divided by 12.3, that's not the right answer. It's 12.3 divided by 212.27. If you mix up this order, it's not good. So this will help you, this method will help you remember how to enter this into your calculator. So you always start with this first number and you move right as if you were reading. So we're going to multiply 12.3 by 1, then divide it by 12.27 grams, cancel out those grams, and we end up with moles. It's a very, very, very small number, isn't it? 0.58 moles. But that makes sense because 1 mole weighs over 200 grams. We have way less than 200 grams, so we definitely have less than a mole. So this number is perfectly reasonable. Sorry about that. Okay, so that is how to do it. I'm going to give you all, let me actually show you a couple of things. I want to show you a couple of videos that you can use that might be helpful. Sorry about this. I got to go back into my, nope, that's not it. Whoop, here we go. If we go to our playlist, let's see if I can find our playlist. I'll show you some other videos you can watch, and then we'll do some examples together. So if we go into our playlist, okay. This video by Tyler DeWitt is very useful. It's called Understanding Conversion Factors. So if you need to learn more about like what a conversion factor is, like that whole centimeter inches thing I was talking about, this is a great thing to watch. And then he has 2 videos that are practice of converting between grams and moles. So if you would like to see more practice done, I'm going to show you a couple of problems from your packet, but this is nice because he'll do even more examples. I think he explains things very similarly to the way I do, but maybe it's just a little bit different and maybe it's a little bit better. Who knows? You can give it a try. So these are 2 videos of just practice converting between grams and moles. It's a total of 16 minutes, 10 minutes and 6 minutes. So that's not bad. And he also has a video about mistakes. So if you think that you are making a lot of mistakes, it might be one of these most common ones, and you can watch this to be aware of those. I will also try to post some more stuff, but I think this should probably do the trick for the most part. Okay. It's kind of weird talking to you all sometimes because there's no one here to interrupt me. I'm just talking to myself, but I have to pretend that I'm talking to you all. It's kind of weird. Okay, let's take a look at the packet and we'll do a couple problems together. So again, we've already solved a few problems here. This is page 1. Let's go to page 2. We also solved the problem. So let's do page 3. Let's do number 4, way down here. Let's do this one. This is a good one. Okay, so how many grams are in 88.1 moles of magnesium? So we are looking for grams, and we've been given 88.1 moles of magnesium. So we are going to need to set up a skeleton. Okay. And we're going to start with 88.1 moles of magnesium. I know that magnesium is Mg. Okay, and we're looking for grams. So I know whatever the molar mass is needs to go here. And I'm going to put 1 mole of magnesium at the bottom because I know that I need some number of grams of magnesium at the top. Molar mass is always some number of grams per 1 mole. So without even going to the periodic table or looking it up, I know this is what I'm going to do. I knew to put it grams over moles because I needed moles to cancel. But now I'm going to go to my periodic table and actually get that number. It's just an element, it's just magnesium, so I don't need to do a lot of math here. It's 24.31. So that means that 1 mole of magnesium has a mass of 24.31 grams. We have considerably more than a mole. We have 88 moles. So this is going to be a pretty big number. It's going to be probably, let's think about this. If this is 25, and let's just say that's 100, we'll round up. That's like 2,500. So it's going to be probably like 1,800 or 2,000. It's going to be a pretty big number. So we can cancel out anything that's on top and bottom. So in that case, this 1 doesn't count. Moles of magnesium is out. And grams of magnesium is going to be our unit. So now we should do some math. So 88.1 times, what was that? 24.31. Okay. Ooh, 2,100. It's less than 24,000. I kind of, sort of guessed vaguely correctly. Okay. Once again, we're going to keep the 2 digits after the decimal point. So 2141.71. Ooh. And the unit is grams of magnesium. And that right there is our answer. Pretty cool, yeah? All right. Let's try another one. This is page 3. You guys also are going to do page 4, but you don't have to do page 5, 6, 7, 8, 9, or 10. We'll skip down to 11 at the end. Oh, you could, no, there's no grades there. That's good. Okay. Let me see which one I would want. I think we're doing odds. We're doing odds. No, we did evens. Even 6. Sure. Let's do 12. I like 12. That one works for me. All right. We're going to go from grams to moles. Yep, perfect. Okay. This time we are trying to solve for moles. So we're looking for moles. And we have 68 grams of copper 2 hydroxide. So let's try to set up our skeleton. The first thing is we're going to put in our information from the problem in the top. We'll leave that bottom corner empty. 68 grams of copper hydroxide. Okay, we're going to need to put in our quality, our molar mass right here. We're trying to get moles. So I know moles are going to have to be on top here. And I know that grams are going to have to be on bottom here. Now, what exactly is the molar mass of copper hydroxide? Well, we're going to have to do this a little bit of math. So it looks to me like copper hydroxide has 1 copper, 2 oxygens, and 2 hydrogens. So let's do a bit of math. All right, so copper has a molar mass of 63.55. There's just one of them. And let's add in 2 oxygens. Oxygen is 16 and hydrogen is 1.01. So that's going to be 16 times 2 plus 1.01 times 2. Okay, so you guys can't see that very well, can you? All right, so the 63.55 is the copper. The 16 times 2 represents the oxygen times, with that 2 is the subscript on the outside of the parentheses. The 1.01 times 2 also that. Some people like to add the oxygen and hydrogen together and then multiply that number times 2. That's fine. You can do that just as well. The math is exactly the same. Doesn't matter. Either way, our answer is 97.57. So let's enter that here. Okay. So again, 97.57 is our molar mass. This whole thing here represents molar mass. Okay, the grams per mole. Molar mass is always grams per 1 mole. X number of grams, some number of grams per 1 mole. Always, 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 always. Okay. Now, the reason that I put the grams on the bottom this time instead of the moles, I flipped it kind of upside down as we normally see it, is because I need grams to cancel. So I've got grams of calcium hydroxide on top. I've got grams of copper hydroxide, copper hydroxide on the bottom. Those cancel. Now we just do some math. So we're going to multiply 68 times 1. Well, that's just going to be 1. And we're going to divide it by 97.57. So I'm going to do that in my calculator, a little bit funky. We do 68 divided by, oops, the 6 on my calculator doesn't always work. Divided by second answer, which for my calculator is 97.5. And we get, oh, this is fun. All right, we're going to round this to 2 places past the decimal. So 0.69, we have to bump it up so that that 9 is going to become a 10. So it's going to actually be 0.90 is how we write this, how you round that up. And that is going to be moles of copper hydroxide. And that is our answer. That makes sense to me because we're taking 68 and dividing it by a number that's a third again as big as it's definitely bigger than 68. So we should end up with a number that's less than 1. So 0.9 seems reasonable. I can buy that. It's kind of like 70 divided by, oh, I just wrote that wrong. No wonder. It's not 0.9, it's 70. That makes more sense. Sorry. I was like, why is it 0.9? It should be more like 0.7. It's because it is 0.7. Okay, so 0.70. I got to tell you, you guys got to keep an eye on me because I will do weird things like that where I'll just mix up the wrong numbers and just put numbers and get confused. All right, so there's a couple of examples. So at this point, you are now you have the knowledge to be able to do page 3 and 4. Page 3, problems 1 through 5 is just based on elements up to 8 on the next page. And then page 11 through 16 is these molar mass with compounds. Now, one thing you're going to notice here is they give you some examples where in this work, and the way that these people, this worksheet, whoever did this worksheet does it, they don't use a skeleton. They instead take the number and multiply it by a fraction. This is a perfectly valid method. If you prefer this, that's great. The only problem is I think that sometimes it's really easy to forget that this number has a little secret invisible 1 on the bottom. And you can get the numbers misaligned and it can cause some problems. So if you like this method better, you can totally use it. I just recommend don't leave a number by itself, just divide it by a 1, just to help you see how these two numbers get multiplied, and like these two are numerators and these two are denominators. Otherwise, it can get a little funky. Okay, I'm going to stop there. You guys can go watch some more videos if you need some more help. Try some of these out. Generate some really good questions. Come up with some specific problems that you want me to talk about. Again, the more specific you are, the better. If you just tell me you're confused or you don't understand, that means nothing to me. But if you tell me a little more specifically, or if you point to a specific problem, I'm going to make you, if you ask me questions, I'm going to make you do that anyway. So you may as well be prepared on the start. All right. Well, good luck to you all. That is the last notes for this unit. The next unit is all about reactions, and it's going to be super exciting. And then unit 6, all of this stuff is going to come back. So we're going to take a little break from the math part, the calculations, but we'll come back for it with a vengeance in unit 6. So I'll see y'all later. There we have it.